minutes tomorrow?
Yes, we can definitely do that. Okay, now the way this works is, hold on a second, let me turn my drawing pad on. You're looking at my screen, and whatever I write on my screen, you should see. Yes?
Yes.
Okay, good. It's the Pythagorean theorem. Okay,
Yes.
so there's two ways that we can, I like the student to always bring the problems to the session. Okay, precalculus is a big area. I don't know what part you're on at the moment, so I would be guessing if I tried to teach you precalc. So the best way to do it is for you to give me problems, and then we will try to solve them together.
Okay.
Okay. Now, some problems can be verbalized relatively easily. Other problems, if they involve graphs and stuff like that, then you need to take a picture of them and send it to my email address.
Okay.
Do you have a book, or are you online only? I mean, are you all of your source materials online?
No, I have my textbook right here.
Okay, what book is it? Who's the authors?
The authors are Blitzer, so it's Pearson.
Okay. Not familiar with that one, but I don't think it matters. Do you have some problems you can verbalize for today? In other words, that are just don't depend on you interpreting a graph. Those are the hard ones to verbalize.
Yes, I have several problems that I can verbalize.
Go ahead and give me one. I'll write it out, and then we'll try to solve it together. That's kind of the way I work.
Okay, so cosine parentheses 45 degrees minus 30 degrees.
So notice that that's the cosine of 15 degrees.
Right.
Which is not one of your common angles. You don't have a special triangle that will give you that.
Right.
So we need to use the sum or difference identity. So let's start there. Always start with the general formula. What is that? What's that equal to? What's the cosine of A plus or minus B equal to?
Is it cosine C?
It's cosine A, cosine B, and then the sign is opposite. It's minus or plus. In other words, if the original one was plus, we're going to do a minus. If the original one was minus, we're going to do a plus. And then the rest of it is follows sine A, sine B. Okay? So we've got the cosine of 45 minus 30. Let's figure it out based on this identity. Cosine of A means what?
I have no clue.
Cosine of 45.
That's.
In other words, this is A. This is B. Okay? So tell me what the rest of it is.
It would be cosine 30 plus.
Is it plus or minus?
Plus.
Okay.
Sine 45, sine 30.
Okay. Now, these are ones that you should have memorized. Remember when you took high school trig, if you took it, they asked you to memorize the unit circle?
I never took high school trig.
Okay. Well, these are unit circle problems. You don't want to have to look that up in the calculator or that or that or that. There's a relatively easy way to do it. Let me show you two triangles that I'm quite certain you've worked with over the years. And that's your 30, 60, 90 and your 45, 45, 90. Commit these to memory if you do not have them committed to memory, because this tells you all of your standard trig functions. Okay? Along with so, ka, toa.
Yeah.
Memorize that. You cannot go further in trig unless you memorize that. And by memorizing the triangles, I mean memorizing the dimensions mainly. The 1, the root 3, and the 2. You with me?
Yeah.
So what's the cosine of 45?
The cosine of 45 would be opposite of sine, so hypotenuse, or yeah, hypotenuse over opposite.
Oh,
So
hold on, it's the adjacent over the hypotenuse.
yeah.
So what is that?
The adjacent, wouldn't it be 1 over square root of 2?
Yeah. Let's not worry about rationalizing that yet. Okay? Different trig teachers treat this differently. Some want you to rationalize always. The new trend in trigonometry teaching is do not rationalize. And you'll see why. So that's cosine of 45. What's cosine of 30? Now you got to look at this triangle over here.
Cosine of 30 is square root of 3 over 2.
Okay, plus, what's the sine of 45 degrees?
Sine. It's 1 over negative, or square root of 2.
Okay, and the sine of 30.
Sine of 30. 1 over 2?
Yeah.
Oh, no.
You want to memorize those. And by that I mean you want to know that the sine of 30 is 1/2 and the cosine of 30 is root 3 over 2. Only because it comes up so frequently. You're always working with these numbers. 1 over root 2, root 3 over 2, 1/2, 1 over root 2. Those just come up all the time. Okay? So you want to be able to instantly draw those from memory. Notice that if you look them up in a calculator, you would get a decimal. You wouldn't get a radical answer.
Right.
And that's important. You do not want to make these decimal answers. Decimal answers for trig functions are rounded off by necessity. If you leave it in radical form, that's a precise answer. Okay? Now, let's continue this. We've got our answer. It's that plus that. What's the first part?
Would it be square root of 3 over square root of 2, 2?
Yeah, let's put the 2 in front always.
Yeah.
Problem with putting it second is that a person can't tell if it's under the radical sign sometimes.
Correct.
So if you have a whole number, always put it in front of the radical. What's the second part?
1 over 2 square root of 2.
So what's a better way to present that answer? That's a fraction, same denominator. How else can we write that?
We could write that as, sorry. Can we do square root of 3 plus 1 over 2 square root of 2?
That's the answer. Okay. And notice that we were able to get that even though we have no triangle that lets us figure out the cosine of 15 degrees. As long as we know the cosines and sines of 45 and 30, we can always get 15. And it's a strange looking answer, but not really. That is a precise answer. That's exact. Now, you may have a teacher that insists that you rationalize your fractions. Does yours do that?
No. He'll just
In other words, do you know how to rationalize that?
I know.
Multiply it by square root of 2 over square root of 2, which gives you this. Now, the reason that's rationalized is because it has a denominator that is a rational number. This does not. That has a denominator that has an irrational number. And normally, mathematics wants you to rationalize everything. They don't like these kind of answers over here, because you can't really divide by an irrational number. How do you split up a piece of pie into square root of 2? You can't do it. But you can split up a piece of pie by 2. So that's the whole reasoning for having rational denominators. However, because trig, your sine, cosine, and tangent are reciprocal to your cosecant, secant, and cotangent, you are frequently flipping these around. In other words, this was the cosine of 45 degrees. Well, if I asked you what the secant of 45 degrees is, I'm going to use this one right here, because if I flip it upside down, I get my answer and I don't have to worry about rationalization. So the new trend in trig is do not rationalize. It's not only not necessary, but it's frequently a waste of time that you have to then spend more time to figure out what the reciprocal is. What else you got?
We'll do a harder one.
Okay.
Cosine parentheses 3 pi over 4 minus pi over 6.
All right. When you are dealing in radians, because that's a relatively new language to you, I'm going to suggest that you convert to degrees. Okay, it isn't absolutely necessary. In other words, we can subtract those two fractions. Let's go ahead and try it. Our common denominator is what?
12.
Okay, so that becomes 9 pi over 12 minus 2 pi over 12. So that's equal to 7 pi over 12. And this one is 3 pi over 4. And this one is pi over 6. That's 135 degrees. That's 30 degrees. So it's two common angles again. In other words, we don't need to convert it to degrees. Just leave it exactly like it is. Because if you know your trig, your standard trig functions, first of all, here, hold on. Let me write, what's the general again?
The general's a plus minus
b. Okay, and then what's it equal to?
Cosine A, cosine B, minus plus sine A, sine B.
Good. So, what's cosine of 3 pi over 4?
So that would have been, so that's a 135.
Correct.
If I'm correct, each other angle is 45.
45, what you said?
Is it 45 though? Each other angle? It is? Okay.
Let's talk about that. Let's look at the unit circle. this is pi all the way around. So 3 pi over 4 is that angle right there.
Right.
Well, there's also a couple of equations that apply here. Here, let me write it in terms of radians. In the second quadrant, you convert it using that formula. In the third quadrant, you convert it using that formula. And in the fourth quadrant, you convert it using this formula. And what I mean by converting it is convert it to a first quadrant angle. That's the easiest way I have found to do trig, using these three formulas. So what is 3 pi over 4? What is the equivalent first quadrant angle there?
Pi minus delta.
What's pi minus theta? Theta is 3 pi over 4. So that's pi over 4, right?
Yeah.
Okay. And the advantage of converting it to a first quadrant angle is that you always know these two triangles. So pi over 4 is which degree?
45.
What's cosine of 45?
Cosine of 45 is 1 over square root of 2.
Now, we need to know whether it's positive or negative, because when you get into the other quadrants, the sign, the plus or minus sign, changes. There's a little acronym, all students take calculus. Have you ever heard of that?
No.
Well, what that tells you is that all 6 trig functions are positive in the first quadrant. Only the sine is positive in the second quadrant, and of course its reciprocal, cosecant. Only the tangent is positive in the third quadrant, and its reciprocal, cotangent. And only the cosine is positive in the fourth quadrant, along with its reciprocal, secant. So which quadrant are we in?
We're in the second.
What's cosine in the second? Plus or minus?
Plus.
Only sine is plus in the second. That means everything else is minus.
Minus. Yeah, minus.
So there's a minus sign in front of that one right there. Now, what's the cosine of pi over 6? First of all, you don't need to convert to degrees, but you can if you want. And I don't blame you. If you are, just now being introduced to radians, it's hard to think in a new language, and that's what radians are. So if you want to convert that to degrees and then figure out what the sine of 30 degrees is, that's fine, or the cosine of 30 degrees. But that's what that is 30 degrees. You with me?
Yeah.
Okay, what's cosine of 30 degrees?
The cosine of 30 degrees is, isn't it? Yeah, it's square root of 3 over 2.
Okay. Is the sign plus or minus? When I say sign, I mean the plus or minus sign.
Yeah.
It's difficult to talk about trig because you have the sine function and you always have a plus or minus sign in front of the function.
It's plus.
Correct, because that's a first quadrant angle. 30 degrees is.
Yep.
Anything between 30 degrees and 90 degrees. Okay, what's my plus or minus sign that follows now?
So it's plus sine of,
what's the sine of 3 pi over 4? And if you want, I always do these exactly the same way. I convert to a first quadrant angle first, using that formula. So what's my first quadrant angle?
Pi over 4.
What's the sine of pi over 4?
The sine of pi over 4 is 1 over -2, or square root of 2.
And is that a plus or a minus in front?
The plus?
Correct. That's a second quadrant angle. Sine is positive in the second quadrant. And finally, what's the sine of B, or 30 degrees?
The sine of B is 1 over 2.
Now we just have to do the algebra. So that's square root of 3 over 2 root 2 plus 1 over 2 root 2. Same answer as the previous problem. Square root of 3 plus 1 over 2 root 2. That's coincidence. Unless they purposely did it like that.
I have no idea, but
Yeah, what's this? 135 degrees minus 30 degrees. No, they were asking about an angle of 105 degrees, which I think the previous one was cosine of 15 degrees.
yeah.
But I think our answers are the same, and that's okay. There's nothing wrong with having the similar answers, because in this unit circle, there's always two quadrants that'll give you the correct answer. Notice that it is the same. Using this formula over here on the far left, pi minus theta, it means 180 minus, and the angle was 15. That's 165. May not be exactly the same answer. I may be remembering it wrong. Might have been root 3 minus 1 over. I don't remember.
Yeah, that's, or, well, because in the equation right under the cosine A, cosine B, you have negative 1 over square root of 2. So wouldn't that make that square root of 3 negative?
Are you talking about this term right here?
Yeah, that in front of it you have a negative.
Is the cosine of B. B is a first quadrant angle, so that's always positive.
Correct.
This is the cosine of a second quadrant angle, so that's always negative. And that is, notice the sign is positive in the second quadrant, so that's always going to be positive, and that's always positive because that's a first quadrant angle. So I'm pretty sure we got our signs correct. Oh, I see what I did. I forgot to stick the minus sign right there. That's what
that's what
I'm about. Okay. Thank you. Yeah. No, that was a typo. So it's not the same as the cosine of 15 degrees. Thank goodness, because it shouldn't. The cosine of 15 degrees should pretty much be the negative of the cosine of 165. But it shouldn't be the same answer, and it isn't. All right. What else do you have, Nico?
So for this one, we have cosine 50 degrees, cosine 20 degrees, plus sine 50 degrees, sine 20 degrees.
Is there a plus or a minus between those two?
A plus.
I knew there was something, because what they're doing is having you go backwards. That's all they're doing. Okay, let's go back to our general. Now, hold on. I didn't write that right. That's A and B. Okay. If I look at this right side of the general, what's A and B?
A is 50, B is 20.
Okay. So what they're really talking about is what? The cosine of what? Is it 50 plus 20 or 50 minus 20?
It would be minus.
Ah, notice we know that one. In other words, you didn't really have to do much math here. You just had to recognize that what you were looking at was the right side of that identity. Correct?
Right.
In other words, A is 50, B is 20, A is 50, B is 20, and we have a plus sign, which means it's really the cosine of A minus B. And that gives us cosine of 30, which we know from our two special triangles. So, as with most all math, they want you to be able to go both ways. They want to be able to give you the left side of the equation and let you figure out the right side, but sometimes they're going to give you the right side of the equation and you have to figure out the left side. Like this. And once you do, it's actually easier to go backwards than it is forwards. Notice I didn't have to do any of these. For
Right.
one thing, I don't know what the cosine of 50 degrees is. Only I got to go to a calculator to get that. So I can't do it manually. And I'm quite certain that they want you to do these without a calculator. Just because everything comes down to one of these common multiples of 30 or 45. Once you get a multiple of 30 or 45, you're supposed to be able to do it in your head based on that unit circle, memorizing it. Now, in reality, the only thing you really have to memorize is the first quadrant. And then you can use all those formulas. In other words, there's quadrant 1, quadrant 2, quadrant 3, quadrant 4. And the formula is 180 minus theta. Theta minus 180. That's easy to remember. And this one's 360 minus theta. And all students take calculus. Now you can figure out everything based on an equivalent first quadrant angle. And you can get all of those from your two triangles. With me?
Yeah.
Let's do another one.
Let's see. Okay, so
Do you have any sine ones? We've done 3 cosine problems. They taught you the sine trig identity. In other words, let's talk about it, because if they haven't taught it to you, they're going to. Why do they teach you this one first is the question. Because once you memorize that one, memorizing the sine is relatively easy. First of all, the sine one has 2 sines and 2 cosines. only they're distributed different. Starts out sine of A, cosine of B. The sign is not the opposite, it's the same. And the rest is automatic. It's got to be sine of B, cosine of A. Because I know I got two sines and two cosines in there. You always have two cosines and two sines. And they teach you this one first because once you memorize that one, this becomes easier to memorize. So do you have any problems like that?
I have there's a sine 45 minus 30.
Okay, it's perfect. It's the same as the sine of 15, which again, we don't know what that is. I don't know what that is. There's no triangle that gives us that. However, by using this sum and difference formula, we can figure it out. So translate it. Tell me all four pieces there.
So it'd be sine 45 cosine 30 plus
This is the same.
it stays the same. So minus sine 30 cosine 45.
Now we know all of those, so let's fill them in. What's the sine of 45?
We just did that. What is the sine of 45?
You can see why you want to memorize these, right?
Yeah, it's 1
You don't
over.
want to have to look them up at all, ever. Because there's 4 of them. If you don't have them memorized, it's really tough.
It's 1 over square root of 2.
What's cosine of 30?
Cosine of 30 is, oh my God, what did we do? It was, square root of 3 over 2.
Okay, do I have the plus and minus signs correct on both of those?
Yeah.
Yeah, because they're both first quadrant angles. So everything's positive in the first quadrant. Now, what's the sine of 30?
Sine of 30 would be, I think it's the same thing. 1 over square root of 2.
No, can't be the same. Sine of 45 cannot be the same as the sine of 30. Sine of 30 is 1/2. If there's one single trig function you want to memorize, it's that one. You want to remember that the sine of 30 is 1/2. What's cosine of 45?
1 over square root of 2.
Yeah, that's the one that's the same. So we end up with square root of 3 minus 1 all over 2 root 2. And that's our answer. And again, that's the only way we can come up with an exact answer. I can't do it. If I put in sine of 15 degrees into your... What kind of calculator do you have, Nico?
I actually don't have a calculator. I
You
use this.
don't have a graphing calculator?
Yeah, I just use the math departments at my school.
Okay.
But it's a TI 85.
Okay. So you can put that in, but it's probably not going to give you that answer. It's going to give you a decimal approximation.
Right.
And they don't want that. They want an exact answer. That's why they have you use these formulas, as opposed to just looking it up in your calculator. All right, let's see. If we're going to go to, for another 10 minutes, we got time for another one?
Yeah. I'm gonna do a hard one for us.
Okay.
Let's do tangent of theta plus pi over 4 equals cosine theta plus sine theta divided by cosine theta minus sine theta.
Okay. What did it do? Prove that this is an identity?
It says verify each identity.
Okay. That's a whole nother section of trig that's everybody's least favorite. I don't happen to mind it myself, because once you get good at this game, it's fun. Okay, yeah. It's like solving Rubik's Cube. Once you get good at it, you love doing it. Well, it's the same way with verifying trig functions. What is the identity for tan of A plus or minus B?
Is it the same as sine?
No, let's see if I can trust my memory. Let me see how close I can guess. I think it's that, but I'm not going to say that without looking it up. You don't get a whole lot of tangents. Hence my problem finding it. You don't have the identity in front of you? If you have it, check and see if that's it.
So for that one, it would be, yeah, you have it correct.
I thought so. Okay. So that becomes tan of theta times tan of pi over 4. What's the tan of pi over 4? Well, hold on. Let me go ahead and fill it in like this. In other words, all I'm doing is using the identity.
Tangent of pi over 4.
Is 1.
It's 1.
Here's your triangle. There's 45. That's pi over 4. 1, 1, root 2. I cannot stress enough that you need to memorize these. You need to know what sine, cosine, and tangent is of 30, 45, and 60. Those are the three. Absolutely have to have those on the tip of your tongue every time. Otherwise, these problems become incredibly difficult. But if you have all of those memorized, it's not so hard. Okay? So that becomes 1. That becomes 1.
Those cancel.
So what I have on the left side of the equation, let me erase some stuff. In other words, that tangent of theta plus pi over 4 is equal to the tangent of theta times 1 all over 1 minus the tangent of theta. Now, that's what I have to prove is equal to that thing on the other side. In other words, I've used the tangent sum and difference formula to convert that to tan of theta over 1 minus tan of theta. Now, what to do next? In other words, we're trying to prove that that's equal to that. Well, they've probably taught you that you want to work with the more complicated side.
Right.
Well, that's clearly the right side. right? The
Yeah.
right side has two terms in the denominator, just like the left side, only it's also got two terms in the numerator. So it's clearly the more complicated side. So let's work with this side and see if we can turn it into this. Doesn't matter really which way you go. Usually they put the more complicated side on the left. But in this case, whenever you see cosine theta minus sine theta, we can't do much with these things, but remember I'm always allowed to multiply any fraction by the number 1. What if I multiply it by this? Hold on a second, I got to think about this for a moment. That's the number 1.
What's the rule for cosine squared minus sine squared?
Well, it's equal to cosine of 2 theta, but that's not helpful here. What you usually want to get is cosine squared plus sine squared.
Right.
Which notice we're going to end up with in the top. So let's go ahead and do this. So that gives us cosine squared of theta plus 2 cosine theta sine theta plus sine squared theta. That's what I get when I multiply that times that.
Right.
And that's all over. This is the difference of perfect squares. So that's cosine squared theta minus sine squared theta. I'm just going to leave it like that for a moment. Notice what my cosine squared plus sine squared, that's 1.
Yeah.
So my numerator now is 1 plus 2 cosine theta sine theta. And my denominator is cosine squared theta minus sine squared theta. Unfortunately, I need to erase some of this stuff so that I have enough room to write. Need a bigger drawing tablet, I guess. Some of these verifying trig identities can be really hard problems. The tougher ones, and this is definitely one of the tougher ones. Okay, so what does that equal to? In other words, we've made this there equal to that. So now can we keep turning it into what we're trying to turn it into? Well, let's see. What can we do at the bottom? We got 1 plus 2 cosine theta sine theta. Cosine squared of theta plus sine squared of theta. Cosine squared plus sine squared equals 1. So I would have to take the sine squared on the other side, minus sine squared. That's what cosine is equal to.
Yeah.
Which means that this denominator becomes cosine squared theta minus 1 minus sine squared theta. Nope, 1 minus cosine squared theta. Which becomes 2 cosine squared theta minus 1. We still aren't getting very many, not getting anywhere. There is a saying, and when you're trying to verify trig functions, that when whatever you're doing doesn't work, then stop and go back and translate everything to sines and cosines and do it like that. So we're almost out of time here, but I'm just going to give you this last tip. We'll finish this problem on our next session.
Okay.
But I just want to tell you what I would do at this point. Since I can't prove it easily, and that happens a lot where, boy, the first time you try, you're taking the wrong path. Well, convert everything to sines and cosines and see what happens. What's tangent of theta in terms of sines and cosines?
Tangent of theta, isn't it sine over cosine?
Sine of theta over cosine of theta. So that's the numerator.
Right.
1 minus sine of theta over cosine of theta. Now notice that everything on the left is in terms of sine and cosine. Everything on the right is in terms of sine and cosine. I'll bet if we do the algebra here, we'll end up with exactly what we're looking at. In fact, I'll do it real quick. Normally I would ask you to do the algebra, but because we're running out of time, I'll do it. So this is cosine of theta minus sine of theta all over cosine of theta.
Mm-hmm.
Flip and multiply, and you have sine of theta over cosine theta minus sine of theta. Is not what we started. That's not what we're trying to prove. Now, I don't know what happened there. The problem with these is there's a lot of algebra you got to do. And if, there may be 15 steps of algebra. And if you make one mistake, you're screwed. Because I obviously made a mistake. I didn't get it to prove. I got it to sine theta over cosine minus sine. It's close, right, but it's not the same thing. It's got to be the same thing. And it could be because I did 15 steps algebra and I made a simple mistake on one of them. And the only way to tell is to go back and completely do it from scratch again. Now, in this case, I'm definitely going to start there and convert those to sines and cosines. That's definitely the way to go. Once you get the left and the right side of the equation in sines and cosines, you can generally manipulate it algebraically so that you can prove that the left side is equal to the right side. Okay? A better way for us to begin this topic is perhaps with a little easier problem. You've started off with a degree of difficulty of 9 on a 10-point scale, and that's never a way to start off anything. If you're learning how to ski, you don't start on the expert slopes. You start on the beginning slopes, you work your way up to the medium, and then you do the expert. Well, this is kind of an expert identity problem.
Well, because yesterday I was doing a bunch of identity problems, and I was doing like very basic ones, like.
And you were doing them fine?
Yeah, like sine multiplied secant. Well,
that's good. If you can do the beginning ones, and if you can do the medium ones, then we're ready for the hard ones. And this is definitely a hard one. I've made a mistake here, and we don't have time to figure out where I made my mistake. So we'll just leave it at that for right now.
Okay.
And we can pick up with this exact problem next time for our second 45-minute session. As long as I have you on the phone, let's have a look at my calendar and see when you want to schedule that. Hold on a second. It's having to load. I got most of tomorrow is available, I believe.
Okay.
There we go. Oh, well, that was for today. And I'm going to make that a 45-minute one. What time would you like tomorrow, Nico?
Let's see. So I have to drive back to school, which will take about 4 hours. But let's do. Does 4 p.m. work for you?
Sure. In fact, earlier the better, but 4 p.m. is fine. If you need to do earlier than that.
Well, the only reason I'm making it 4 p.m. is just to give myself a cushion so I can get back to campus and be there.
Okay. How long does it take you to drive from here to Mesa?
About 4.5 hours, depending on traffic.
Okay, so what I will do tomorrow, since you already have the software on your computer there,
Yeah.
and you should have, let's just check your desktop and see if you have an icon that looks like this orange flower that I'm pointing at.
Yeah, I have it right here.
Okay, so tomorrow is all you have to do is double click on that and input the 9-digit meeting ID number that I will text to your phone.
Okay.
Okay, so I won't call you. I'll just text that meeting ID number about 5 minutes before your session.
Okay.
And then just pull up, go to meeting, load it in, and we'll be in a session.
Okay.
Okay? Nico,
Awesome.
I will talk to you tomorrow at 4 o'clock.
Thank you, David.
You're welcome. Bye-bye.
Bye.